Everything has a why. Drop a mouse down a mine shaft 1,000 yards deep. It hits the bottom, shakes itself off, and walks away. The same fall would kill you, and the reason isn't that the mouse is tougher than you. It's something much stranger. Here's the ladder. A mouse walks away. A rat is killed. A man is broken. A horse splashes. Same fall, 4 endings. That line comes from a famous 1920s essay by the biologist J.B.S. Haldane called On Being the Right Size. The rat is the hinge of that ladder. Just a little bigger than a mouse, and the very same fall flips from a walkaway into a killer. Now notice the trap most people fall into. They say the mouse lives because it's light, so it just doesn't hit very hard. That's true, but it's only half the answer. Being light matters. The real puzzle is why being light helps so unbelievably much. To see it, look at what really changes when you shrink an animal. It isn't just lighter. It's reshaped in a hidden way. Take any shape and make it 10 times smaller in every direction. Its surface, the skin on the outside, shrinks to 100th. But its volume, all the stuff packed inside, shrinks to 1,000th. And weight follows the inside, not the skin. So the small animal keeps a lot of skin but loses almost all its weight. Suddenly, it's nearly all surface, with barely any mass. Picture a sugar cube versus the same sugar ground to powder. Grinding it small exposes enormous surface. A tiny body is like that powder. It's why dust hangs in a sunbeam instead of dropping. Each speck is almost pure surface, so the gentlest air holds it up. And surface is exactly what grabs the air. More skin-catching air, far less weight pulling down. That balance is the whole secret. Haldane did the sum himself. Shrink the animal tenfold, and its air resistance compared to its weight becomes about 10 times stronger. Haldane added one honest catch. Provided the ground is fairly soft, even a mouse meets its limit on bare rock or against a hard edge. You can watch this in your own backyard. Every spring, baby birds tumble out of high nests, hit the ground, and hop away just fine. A drop that looks terrifying from way up there is, for a creature that small, barely a stumble. It's the same physics as the mouse. So the first answer is this: the mouse doesn't survive because it's strong. It survives because of its shape and its size. But that raises a sharper question. If air catches small things so well, how fast does a falling animal actually end up going? When you fall, you don't speed up forever. Gravity pulls you down, but air pushes back, and that push grows as you go faster. And that push depends on how much of you faces the wind. Spread wide and the air grabs a lot. Ball up tight and it grabs much less. At some point the upward push exactly equals your weight. The forces cancel. You stop speeding up and you simply coast. That's terminal velocity. For a skydiver falling belly down, that coasting speed is about 120 miles an hour. Fast enough to be deadly. Even you can change your own top speed. Belly down and spread, you fall slower. Diving headfirst like an arrow, you fall noticeably faster. It's exactly how a parachute works. It doesn't add weight. It adds surface, a huge sheet of it, so the air can hold you to a gentle speed. Now here's the part that breaks people's intuition. Make the animal much, much smaller, and that top speed barely drops at all. Scientists worked out the rule. Terminal speed grows only with the 6th root of weight. The 6th root, that is an astonishingly weak link. To fall just twice as fast, you'd have to become 64 times heavier. Size barely moves the needle. That's how weak the link is. Put it the other way, you can make something 10,000 times heavier, and it falls only about 5 times faster. That's the magic. So a bear, plunging at maybe 150 miles an hour, is only about 5 times faster than a mouse drifting down at 30. 30 miles an hour is a speed a tiny, well-built body can simply shrug off. The mouse never becomes dangerous in the first place. The simple rule is this: more weight makes you fall faster. More surface makes you fall slower. A small animal is light and broad at once, so it wins twice. Some animals lean into this on purpose. A flying squirrel stretches a flap of skin into a wide sail, turning a fall into a slow, steered glide. Cats sit in between. An average house cat, falling spread out, tops out near 100 kilometers an hour after about 5 floors. And once a cat hits that top speed, it stops accelerating. Falling from the 8th floor or the 20th, it arrives at the very same speed. That's the second answer. Small animals don't survive fast falls. They survive because for them, a fall is never really that fast. But speed is only half of a crash. What truly breaks a body is the energy it has to swallow when it stops. And size rigs that too. The energy in a moving thing depends on 2 things: how heavy it is and how fast it's going, with speed counting double. The small animal loses on both counts at once. It weighs almost nothing, and it's barely moving. So it carries almost no energy. You lose on both counts the other way. You weigh thousands of times more, and you're moving 4 times faster. The energy is staggering. And all of that energy has to vanish in a few thousandths of a second, soaked up by bone and tissue in the instant you stop. In that instant, you slam from full speed to a dead stop. The faster you arrive, the more violent that halt, and your insides feel every bit of it. Here's the cruel twist of size. The energy you must absorb grows with your volume. But the strength of your bones grows only with their cross-section. So as bodies get bigger, the load races ahead and the support falls behind. The structure simply can't keep up with what it has to survive. That's why Haldane said a horse splashes. It isn't an insult, it's geometry. A body that large has no way to absorb that much energy. It's the same rule that shapes giants. An elephant needs thick, pillar-like legs because its weight grew far faster than the bone holding it up. It's also why a mouse blown up to the size of an elephant couldn't exist. Its twig-thin legs would shatter under its own enormous new weight. The small animal also spreads its tiny landing force across a relatively wide body. Light, slow, and well cushioned, all at the same time. So the third answer: big bodies don't just fall harder, they're built with relatively less to absorb the very crash that their size creates. Now, cats. Cats are the famous case, and they come with a story so strange that for decades people got it completely backwards. In 1987, 2 vets in New York studied 132 cats that had fallen out of high-rise windows. The headline number was astonishing. Of the cats they treated, 90% survived. Some had fallen from as high as the 32nd floor. But then came the twist that made headlines. The cats that fell from higher floors seemed to arrive with fewer injuries, not more. They even pinned a number on it. Above about 7 floors, they argued, a cat has already reached top speed, so the extra height stops mattering. Their explanation sounded beautiful. Once a cat stops accelerating, it relaxes, spreads out flat, and floats down like a furry little parachute. And part of that is real physics. Spreading out genuinely does increase drag and shave a little off your falling speed. But here's where we have to be honest. That famous result is mostly a trick of the data. And the trick has a name. Vets only ever see the cats that arrive at the clinic. A cat that falls from very high and dies on impact is never brought in at all. So the very worst high-floor falls quietly vanish from the data. The survivors that remain only look unusually unhurt because the dead were erased. This is survivorship bias, the same mistake as studying only the warplanes that made it home. The ones that were shot down are simply invisible. And when scientists finally gathered enough cases, the illusion broke. A 2025 study followed over 1,100 fallen cats. An earlier study of 119 cats had hinted at the same thing. Survival was high, but injuries climbed steadily the higher the fall. With that many cats, the pattern was clear and ordinary. The higher the fall, the worse the injuries. A straight, rising line. Survival stayed high for shorter falls, then dropped off for the worst ones. Cats are remarkable. But falling further is not secretly safer. So cats really are built to fall well. But the magic isn't extra height, it's the same small body physics, plus one more trick. That extra trick is the thing everyone has seen. A cat dropped upside down still somehow lands on its feet. How is that even possible? A spinning skater speeds up by pulling their arms in. A cat uses that same rule, but to twist its body when it had no spin to begin with. It bends in the middle. It tucks the front legs in to spin the front half quickly, while the back half barely turns. Then it swaps. Pull the back legs in, swing the rear around, and the whole cat has turned feet down without ever having any overall spin. Pure body control. The reflex is so quick it needs only a fraction of a second, barely one floor of falling, to bring those paws around to face the ground. And cats aren't even unique. Squirrels routinely fall from the very tops of trees, bounce and scamper off. Smallness is the common thread. Push this whole story to its smallest extreme, and you get something almost unkillable. An ant can fall off a skyscraper and just walk away. At that size, the air itself feels thick, almost like syrup. A speck of a body meets so much resistance that it just drifts down gently. To be fair, nobody has carefully clocked an ant's falling speed. But the physics all points one way. Below a certain size, falling stops being dangerous. So every level of this story is really one single idea. Shrink a body, and the air quietly becomes a parachute it was born with. So why can a mouse survive a fall that would kill you? Not because it's tough. Because it's small, and smallness changes the physics of falling. It's not invincible. Soft ground, a lucky landing, the right posture, all still matter. This is about scale, not about magic, which leaves one last question. If being small is so safe, why did nature ever build anything as fragile and enormous as us? That's another why. Like and subscribe for more.